Hi and welcome to Maths class. Today we're looking at applications of integration, and the first application we're looking at is average value of a function. Now first, before we start learning how to calculate this, we need to understand what that means. So the average value of a function is defined in a particular way. So you can see the first diagram that I've got there. What you can see is a function y equals f of x, and then I've got an interval from a to b. Okay, so I've just drawn two vertical lines from A and B to help me see where the function meets those, where on the function those x values are, where x is A and where x is B on the function. But also what I've drawn there is a horizontal line. Now the horizontal line is the line that makes a particular rectangle. So if you have a look there, you can see, hang on a sec. So if you have a look, hang on. So what I've done in this first diagram here is I've copied down the image of the function and I've shaded, oops, didn't mean to do that, and I've shaded the area under the graph, okay? Now in this second diagram here, what I've done is I've shaded the area under the line that makes a rectangle that has a width of b minus a here, and it has some height. But whatever that height is, it's going to make these two shaded areas the same. So basically, the shaded areas are the same. So in order to calculate the average value of a function, that average value is given by the height here of the rectangle. So as soon as I can work out the height of the rectangle, then I can work out the area of the rectangle. So for now, I'm just going to call it h for height, all right? So this is what I've got. So what I've got there are two areas. On the left diagram, you can see the area under the graph can be found using the definite integral over the interval from a to b of the function f of x dx. So that'll give me the shaded area in this first diagram. In my second diagram, the shaded area is the area of a rectangle. So I can just do the height times the width. The height of the rectangle is h. The width is the distance from a to b. So that's given by b minus a. But the height here, this is actually what I'm looking for when I say the average value of a function. So what I can do then is if I make these equal, I end up with this equation. So what I've got there, I've simply made the two areas equal. h times b minus a is equal to the integral from a to b of f of x dx. So if I want the average value of a function, h, then I'm just going to divide the right-hand side by b minus a and include the rest of the integral. So this equation gives us the average value of a function. So again, just to remind you what the definition of that is, it's going to be the height such that the area under the rectangle is the same as the area under the graph. So when we say average value of a function, how would I in fact find the average value of f of x from a to b? I can't just find the mean because it's a continuous function. I've got an infinite number of values there. So this is the method that we've used to find an average value of the function. And there you can see the definition. The average value of a function for an interval from a to b is defined as 1 over b minus a from a to b f of x dx. So here's a worked example, and what I've done is I've just started writing down my solution. So find the average value of f of x equals 2x squared for the interval from 1 to 4. Find the value of x that corresponds to the average value. So this question makes us remember that actually the average value is a y value, and I need to then find the value of x that corresponds to this value. So let's do this. I've written down the equation or the formula for the average value. It's 1 over b minus a from a to b of f of x dx. So let's rewrite that using the information that we're given here. I've got 1 over 4 minus 1, going from 1 to 4, and my function is 2x squared dx. So I simplify and I start my calculations. I've got 1/3, and this is going to become 2x cubed over 3. And again, my terminals are from 1 to 4. So now all I need to do is substitute and do my calculations. So 1/3 times. So there it is. I've substituted in my 4, and then I've substituted in my 1 and done my subtraction. It gives me 126 over 9, which simplifies to 14. But I've only done half the question. Now I need to find the value of x that corresponds to this value. So in other words, I need to know when is 2x squared equal to 14. And that's simple enough to do. X squared is going to give me 7, which means x is going to be plus or minus the square root of 7. But then I look at the interval. My interval is from 1 to 4, but x is from 1 to 4. So x equals positive square root of 7. Now, I know I don't need to drum this home to you by now, but note that there were 2 solutions to my original equation. So of course I found both solutions and gave a reason why I selected the one that I did.